Welcome back, Algebra 1 students. We are in lesson 35, and we are going to learn something about, we learned greatest common factor in the previous lesson about how to find the greatest common factor of variables. So I want to back up just a little bit. We're gonna proceed on to that a little bit more, but first I'm going to talk or refresh your memory of the distributive property. Right, so we learned how to distribute using the distributive property. We illustrated it like this: A times B plus C equals AB plus AC. Remember that? That's our rule for distributing, for the distributive property. We take A and we apply it to B, and we take A and we apply it to C. And we do that for every term in the parentheses. We know that this means multiplication, so it's A times B. So when we look at this, we can see the parts and we can tell that A and B are both factors of this term. We can tell just by looking, we can understand that we could take A back out of each one of these terms. A would be the greatest common factor, right? And it looks like this when we don't distribute it. When we pull it out of each one, it is the reverse of the distributive property. That is what the greatest common factor is all about. It is about simplifying a long expression into something that we can factor, which might actually help us to reduce something that makes the problem more solvable. So keep in mind, that's all it is. It is the inverse operation. Factoring is the inverse operation of distribution. So we are doing the opposite. First we learned to multiply everything. Now we're learning to factor it out. So we're just going back and forth, and we're learning that relationship between our numbers and how to break them down and group them in our heads and group them on paper if you need paper, so we can see their components and understand the relationship that they have with each other. So let's move on to factoring the greatest common factor. And I want you to keep this. I'm going to move it over here because I want you to see how that works and how it's just distribution undone, so to speak. So let's do example 35.1. And we are going to factor the greatest common factor from this problem. We have 2ax plus 2a, this is an A supposedly, if I can get my pen to stop skipping, AC. Alright, so the first thing we need to do is look at our constants. What do we have that is the same in both? Oh, well, 2. 2 is the same number in both. That one's pretty easy. So we have a 2 that's common, right? What else do we have? Let's look at our variables. We have an A in this one and an X in this one. We have an A in the second one and a C in the second one. Well, the only thing that's in both is the letter A. So let's write the A. 2A is our greatest common factor. But that's not all that's in the expression. We still have these other things in the expression. We don't want to just throw those away. We want to keep track of them. So we're going to put a parenthesis here, and we're going to take the difference between 2a and this term, which is x, bring down our operation, and take the difference between 2a and what's in this term, and that's c, and close the parenthesis because that's the end of the expression. Isn't that what we did here? Can you see how we just undid our distribution? We had 2a distributed to x and c. Well, now we just went backwards and we took it out of the 2ax and the 2ac. That is what factoring is. You find the greatest common factor and you take it out of each of the terms. Now we have two factors in this expression. We have this is multiplied by this. Right? So that is a skill that we need to understand. We need to fully comprehend that this is the opposite of distribution. Okay? And be able to go backwards and forwards with our factoring and our distribution and be able to see that, see those parts. Let's do 35.2. All right, this is a little bit longer and it's all variables. So it is going to be maybe a little bit more complicated. That's okay. That is okay. The more complicated it is, the more practice we get and the more our brain stretches. When our brain stretches out, we can do more with it. It's kind of like your muscles. Your brain is almost like a muscle. When you stretch your muscles, you work your muscles, they are stronger and they can do more and they can carry more. They can do more work. The same is true with your brain. The more you stretch it, the more you challenge yourself mentally, the more you will be capable of mentally. It is just like a muscle. So treat it that way. Challenge your brain. Be smarter than you were yesterday. So let's look at what we have here. We have a cubed x squared m squared plus a squared xm cubed minus a to the fourth x cubed m squared. So let's pull out what's common first. All right, we have an A3, an A2, and an A4. Well, we can get an A2 out of this, and out of this, and out of this. So that's the best we can do for the A's, is pull 2 out of each one. That's what's common. Now, what's common with the x's, we have an x to the 1 right here. Remember I said that if you only have x to the 1, you don't even have to look at the rest of them. The only thing you have to do is verify that there is an x in the others. Because when x to the 1 is your smallest one, that's all you can take out of all of them is 1. Right? That's your greatest common. Don't let the greatest common fool you. It doesn't mean the biggest number. It means the whatever value happens in all of the terms. Okay, it is the most common. Instead of greatest, think most common factor. The most common factor for x is x to the 1. Now we have m. M is in all three terms. Now we just have to figure out what exponent. We have m2, m3, and m2. We have two 2's. So we can pull m2 out of all three of these terms. Now let's see what's left. When we take a2 from a3, we're left with a to the 1. We take x to the 1 away from a2, we are left with an x. When we take m2 from m2, we're left with m0, which is 1, which we do not write because we understand there's already a 1 here in front of our variable. We bring down the operation and we compare again. A2 from A2, there are no A's left. So that's over. X and X, they're both to the 1, so we don't have any X's left in this term. We have m squared and m cubed. Well, 3 minus 2 leaves 1 m behind. And it's understood that the little m has a little 1 right there, so we don't have to write it. We bring down our next operation, and we compare again. A4 minus A2, that's going to be A squared left. X3 minus this X is just going to be X2. And M2 minus M2, there's no M's left. So that's the end of our factoring. So this is what we would have for the answer of 35.2. It's pretty simple when you look at it in those terms. Don't overcomplicate it. Do not overcomplicate it. We know that when we have exponents, they're just that, it's just that variable used that many times. That's all it is. So we can treat this like a count. A 3 times. When we take 2 times away, we're only left with 1 time. That's all it is. Don't overcomplicate it. But you can see again, it's the reverse of distribution. We went from here to here with distribution. Factoring goes from here to here. All right? I believe, yes, we have just a few more. And I'm going to let you do this next one on your own. So I'm going to clear the page and write it out for you. And it is 30. Actually, I'm going to write all 3 of these out for you and allow you to do them on your own. And then we will compare notes. All right, so I've written out these 3 problems for you. And I would like for you to find the greatest common factor and then factor that out of the rest of the problem like we did for 35.1 and 35.2. So pause, write these down, and then work the problems, and then press play and see if you and I have the same result. And if you have the same thing I do, then you did it right. If not, if you didn't have it right, then you need to watch the rest of the video and walk through it with me, okay? If you got them all right, you can skip to the end. How about that? All right, so pause, work these out, and then you can press play.